So welcome all of you for this lecture on engineering materials and metallurgy. Engineering materials refers to the group of materials that are used in the construction of man-made structures and components. Engineering materials should withstand load within allowed deflection level. Major classification of the engineering material includes metals, polymers, ceramics and composites. So metals are the most commonly used engineering material that include ferrous as well as non-ferrous materials. Polymers may be classified as thermoplastics and thermosetting plastics and elastomers. Ceramics are solid compounds that may consist of metallic or non-metallic elements. The primary classification of ceramic includes glasses, cements, clay products, refractories, and abrasives. Ceramics generally have excellent corrosion and wear resistance, high melting temperature, high stiffness, and low electrical and thermal conductivity. Ceramics are also very brittle materials. Composite materials are something that is composed of a minimum of two materials. It combines to serve properties of superior to the properties of individual constituents. So even though we have a lot of materials existing in the world, so as far as engineering materials and metallurgy, this particular subject is concerned, we are more concerned with the materials which is useful for engineering applications, especially mechanical engineering. So that's why we focus more on so this probably ferrous and non-ferrous materials, then composites, plastics like that. So metallurgy is used to study the physical and chemical behavior of metallic elements. So this is important. So we can analyze and find out or compare, and it is useful for making analysis. So metallurgy is used to study the physical and chemical behavior of metallic elements. It includes and science and technology of metals and its production. The science of metallurgy is further subdivided into two broad categories: chemical metallurgy and physical metallurgy. Chemical metallurgy is chiefly concerned with reduction and oxidation of metals and the chemical performance of metals. In contrast, physical metallurgy focuses on the mechanical properties of metals, physical properties of metals, and the physical performance of the metals. So here we try to focus more on physical metallurgy rather than chemical metallurgy, because as far as mechanical engineering is concerned, so mechanical and physical properties are important. Mechanical properties is the most important thing which we are going to do. So usually when you take metals, they are opaque lustrous elements that are good conductors of heat and electricity. Most metals are malleable and ductile and are in general denser than the other elemental substances. The most abundant varieties in the earth crust are aluminium, iron, calcium, sodium, potassium and magnesium. So as far as mechanical engineering is concerned, we deal more with iron, then after that, so non-ferrous materials like aluminum, copper, etc. So metals are usually crystalline solids. The mechanical properties of metals such as hardness, ability to resist repeated stressing, that is fatigue strength, ductility and malleability are often attributed to defects or imperfection in their crystal lattice structure. So everybody know that iron is a chemical element with a symbol Fe. So these are all some of the examples of what is it, pig iron, cast iron, wrought iron, and steel. So each have a different element. Iron may be a predominant element, but in addition to iron, so some other elements also added. So based on that, it has been classified as pig iron, cast iron, wrought iron, and steel. So you can see some of the non-ferrous materials. So like brass, bronze, then copper, aluminum, like that. So there are ferrous materials like cast iron. Okay. So all those things are so displayed here. So cast iron is basically an alloy that contains 2 to 4% carbon along with varying amount of silicon, so approximately 1%, and manganese and traces of impurities such as sulfur and phosphorus. So these are minimum quantity. So probably less than 1%, all those elements are there. So in general, cast iron or brittle material. So except for malleable cast iron. So with its relatively low melting point, good fluidity, castability, excellent machinability, resistance to deformation, and wear resistance. So these are all the important characteristics of cast iron. So it is having, when compared to steel, it is having relatively low melting point. Fluidity is better. Machinability is also good. So resistance to deformation and wear resistance, so and wear resistance. This is also good. So there are different types of cast iron. They are grey cast iron, white cast iron, malleable cast iron, and ductile iron. So next to steel. So steel is basically an alloy of iron and various other metals which are used to enhance their properties. Strength, resistance to corrosion, tolerance of heat, etc. Changing the type and amount of elements alloyed with iron can produce different type of steels. The most common steels are carbon steels, which contain between 0.5 and 1.5 percentage of carbon. Low alloy steel, which contain 1 to 1.5. Okay, other metals often nickel or tungsten or some of the alloying elements. Nickel steel can withstand high level of tension. High alloy steels probably, so which contain 12 to 18% of other materials. So alloying elements are containing more amount, that is up to 18%. So probably chromium, nickel, so molybdenum, tungsten. So it's all other high alloy steels. Okay. So carbon steel is normally used. So you have low carbon steel, medium carbon steel, and high carbon steel. Low alloy steel is a steel with lesser alloying elements, up to 5% of alloying element. High alloy steel, say it is in the range of 12 to 18% of alloying elements.